Hello, everyone. Keep in mind that on our document that is housing our assignments, that I'm going to pull up to the top where we are. So we are beginning our third unit in circular trig, and the rest of everything is at the bottom of it. So if you need to get anything from the functions unit, it is now at the bottom. You just need to scroll down to the bottom and tap on what you need, and then above that is the exponents and logarithms if you need anything there. So remember that always at the top I'm going to have everything. So there's some notes to download, and of course hopefully these video lessons will be done today. So to start off with, I want to get a couple of screens up here. And so I always get the questions every year. What in the world does winding a right triangle around a circle of radius 1 have to do with anything in the world other than circular trig? So this is what we're doing. We're taking a right triangle and we are winding it around. We got stuck there. A circle of radius 1. Let me pull this down. And we are interested in this because where it leads to is what is called function trigonometry. So you see over here on the right this wave. And what produces this wave is that we take the circle, the unit circle, a circle of radius 1, we cut it and we lay it as the x-axis. So the angles, as we kind of wind around here, that are swept out are going to be the x-axis, and it's important to have knowledge of angles and where you're at when you sweep around the circle. Also, what produces the wave itself, so if you watch like the vertical side of the right triangle, how it goes up and then it comes back down, so that's this part right here. If this is the sine function, and then it comes down and the triangle disappears. And then notice how it goes down to -1. So that's this part in here if it's the sine function again, the vertical side. And then it comes back up to 0 right there. And I have a demo later on that I'll show you that literally shows exactly how that's produced. But the point is, we need to learn things in a circular perspective to get to this point in understanding function trigonometry. We need to learn about angles. We need to learn about the sine ratio when the triangle is positioned at any particular point, and also when the triangle collapses. So this is just a little demo of wherever you're at in the unit circle and all the different things that can be done. And we're just going to focus on a couple of things. Pre-calc students, future pre-calc students, have a couple of assignments where we really get into like doing all of these 6 ratios at all the special locations around the unit circle. Those couple of assignments, you can keep and you can use next year in pre-calc, but the rest of the class will not have that. So anyway, we're going to today learn about angle measures, okay, and how to convert from degrees to radians. So before I put this away, radians measure on the unit circle, which is a circle of radius 1, is just the length of the circle that's swept out as you stop and make a right triangle. So here you see if I stop right here, I have a degree measure 39.8 degrees approximately and 0.6945 radians. So that's the length right here that we swept out on the circle, and that corresponds to this angle measure. And what we're going to learn about today is how to convert back and forth between those two. And that's important again because we're eventually going to be cutting this circle, laying it as the x-axis when we study function trigonometry, and then the sine and cosine waves are going to be just the fluctuations in the sides of the vertical side, which will be sine, and then the horizontal side, which will be cosine. We'll get more into why is it sine for the vertical side, why is it cosine for the horizontal side tomorrow. Today, we just want to learn how to convert and then learn how to identify angle measures. So I am going to now go to my overhead and click off on these windows here. Get my overhead up, and there it is. And you're going to want to read your note packet. So the big thing in going from degrees to radians are these conversion factors, and I'll give you an easy way of remembering them. I just think of it like this. A radian measure usually has pi in the expression. Okay, so if we wrap one time around the circle with radius 1, the circumference is 2 pi r. Radius is 1, so one time around is 2 pi radians. That corresponds to 360 degrees, which, by the way, I recommend you reading through these pages. Not really exciting reading, but looking at them, you know, clockwise as I swept those triangles out, or I'm sorry, counterclockwise as I swept those triangles out, that's a positive angle measure. Clockwise is a negative angle measure. We'll get into this in the assignment today, but I recommend reading through this before you begin the assignment. So conversion factors, going from degrees to radians, you're going to multiply by pi over 180, and it has to do with canceling the degrees. That's why you do that. You want to actually get the units correct. So I think of it as putting pi in the answer. So I need it in the numerator. And then when I'm going from radians to degrees, I usually have pi in the radian measure, so I need to cancel it out. So you're going to multiply by 180 over pi to cancel the pi out. And these are just the results, but you'll see how it works. Why is it these things? Because the conversion factor is obtained by dividing, you know, both sides of this by 360 or both sides of this by 2 pi, and it equals 1 when you do that. So that's the conversion factor that we use, or fraction that we use to do this. So what does it look like? Now, remember, 90 degrees, okay? We need to put pi in the answer, so we're going to multiply this by pi over 180. And I'm going to tell you, you're going to want a calculator with a good fraction entry tool on it, because there's going to be a ton of fractions that you're going to have to simplify and reduce. So here, I want to cancel pi out of, and we'll go back and do the answers when I'm done doing this. We want to cancel the pi out. So you multiply by 180 over pi. It's just a good way to remember how to do this. So again, we want to cancel pi out. So 180 over pi. 240, we want to put pi in here. I also want you, when you use your calculator, to think of pi like a variable when you use your calculator. And I'll explain that. So here we're going to multiply by pi over 180. And then 17 pi over 2, we're going to multiply by 180 over pi. So back up to the top here, you're going to need a calculator that has a really good fraction. Now, you should be able to do this without an entry in your calculator. 90 over 180 is just 1 over 2. But what I'm saying is treat the pi as an x, and so it's just 1 over 180 if you were entering this in, which again you shouldn't need to do. So that's 1/2. So then you just put pi back in the top. So pi over 2 is 90 degrees in terms of radians. So these first three actually are what I call quadrant angles, or benchmark angles is another word that's used. So on this problem, you have 3 times 180 over 2. So what's that going to look like? Well, again, you need to be really good at your math or know how to use your fraction tool, your fraction entry tool, with the note that the pi's drop out. So this is 270 degrees. This obviously is 180 degrees. Okay, so on and so forth. And you get the idea. I'm going to jot down the answers now. So this is going to be 4/3 when you reduce it. So it's 4 pi over 3. Remember to leave the pi out of the calculation. So negative 120 over 180 is negative 2/3. So you just put the pi in again in the numerator. And 17 times 180 over 2 is 1,530 degrees. So how to convert back and forth, it's very important that you commit that to memory. Again, multiply by pi over 180 degrees to radians. You want to put pi in the answer. Multiply by 180 over pi. If going from radians to degrees, you want to cancel pi out of the radian measure. Very, very important. It's also important that you read through this. Now we're going to learn about how to properly determine where you are on the unit circle. This is very important material. So when you measure angles, counterclockwise rotation, as you saw me spinning that triangle around, is a positive measure. A clockwise rotation is a negative measure. Now, if the unit circle is involved in determining angle measure, each scale mark is 15 degrees. So if you see scale marks, now why would we want to scale a circle? Because the circle becomes the x-axis when we start function trig. And each little mark is going to be 15 degrees or pi over 12. So you just need to count. So if this were your problem, and this is what you would be given, you wouldn't see these two. You'd be figuring this out. You'd count 9 scale marks over and either do 9 times 15 to get 135 or 9 times pi over 12. Because each little mark is 15 degrees or pi over 12. It's very important that you know that. I'm going to say that 1,000,000 times. When it's scaled, each little mark is 15 degrees or pi over 12. So all of these, you need to commit to memory. All the way around is 24 scale marks. 24 times 15 is 360. 24 times pi over 12 is 2 pi. A quarter of the way around, well, that's 6. 6 times 15 is 90. And 6 times pi over 12 is pi over 2. So on and so forth. Halfway around, that's 12. 12 times 15 is 180. 12 times pi over 12 is pi. So on and so forth. If you don't have scale marks, this is how things are going to look. You need to use what I call quadrant adjustments. Okay, so if you had this and you wanted, and there were no scale marks, you've got pi plus pi over 6 to do. On your calculator, you would do 1 plus 1/6. Treat the pi like a variable, and then put the pi in the answer. And there's all these different cases here. And then you can also have several rotations happening. So the second part of your assignment. Literally, if you don't have scale marks, it's going to be one of these 4, the idea. And then if you do have scale marks, you have to count and then put it in radians if you don't see degrees. Radians is used more widely. So this is going to be pi plus pi over 6. Why? Because halfway is pi. Commit that to memory. 1 plus 1/6 is 7/6. And then you put the pi in afterwards. 7 pi over 6. So here we're going to count 3. So that's 45 degrees. But I want it in radians, so it's 3 times pi over 12. Remember that every tick mark is pi over 12. You're just going to reduce 3/12. Do not type pi in ever until we get to arc length. Here, this is halfway, 180 degrees. But I want it in radians if it's not given to you in degrees. Here we've got scale marks again. So 3/4 of the way is 18, 6 in each quadrant, 19, 20. So this is 20 times pi over 12. Very simple. Once you know each little tick mark is pi over 12. Not hard to do. That ends up being 5 pi over 3. Now, what about degrees? Are we ever going to have one with degrees? We will. Okay, so here I've got this labeled in degrees, 45. So we're going to do 90 plus 45. That's 135. So you're either going to have scale marks or not. If you don't, you have to use the quadrants to help you. The quadrant positions. 10 has scale marks. So where are we? 6, 7, 8, 9, 10. So this is 10 times pi over 12. What is that? You reduce 10 over 12. Now, we've been moving in the positive direction the whole time. Note that eventually we're going to move in the negative direction. Here, 3/4 of the way around. Commit this to memory. 3 pi over 2. It's actually 18 times pi over 12 on the tick marks, which is reduce 18/12 reduces to 3/2. Okay, so here, 12, 13, 14, 15, 16. So this is 16 times pi over 12. And that reduces to 4 pi over 3. Here, no tick marks, so we got to do 3 pi over 2. That's 3/4 of the way around, plus pi over 3. Again, treat the pi like, so this is what it would, like a variable, 3/2 plus 1/3. This is what you would do. Get it in the screen here. That's 11/6. So this is 11 pi over 6. Now what about going the other way? So if you go clockwise, it's negative. So we have negative 10 times pi over 12. And that reduces to negative 5 pi over 6. Here, all the way around without scale marks. So this is 30. This would be 270. Back up 30. So negative 240 would be like this. So you go backwards. So the other way is positive. Go all the way to 270, then you come back. And then you can have multiple revolutions. So once, twice, and it's degrees. So twice is 720. Once around is 360, twice is 720 plus 30. Not too bad, actually. You need to study this. You need to read this. You won't understand it the first time, most likely. But if you keep reading it and rereading it and rereading it and rereading it, do your work, it'll start to make sense. And again, what this is we're winding a right triangle around a circle of radius 1. Why is that happening? Because it is the fundamentals of moving to function trigonometry, which we'll learn a little bit more about later.